Hi, so welcome to today's lesson. So let's take a look at the final segment of your mole concept. So remember yesterday I mentioned about your percentage parity, percentage yield. Remember the percentage should never be more than 100%, right? Remember the 200%. Remember this? The 200% pure gold necklace. Scam, right? Or your 10 gram of ore that has a percentage purity of 200% gold. Scam. So the percentage yield, percentage purity should never be more than 100%. The maximum is 100%. So now let's go into how to do such questions. All right, let's take a look. So actually, let's take a break. Before we start to do the percentage yield and percentage purity, let's do a quick revision of what we have learned so far. Let's do 2 questions as a quick revision. The questions are here. So this is the first question. So what you can do now is you should pause the video, take your time to do the questions, after which continue. All right? Okay, pause. Once you're done, you can resume. Okay, now let's take a look. How do we do this? So remember your hashtag hack. Number 1 is balance chemical equation. Which in this case is given. Yay! Second step, you will convert the numbers given to mole as much as you can. And lastly, mole ratio. So this doesn't fail. So first step is already given, well done. Second step, let's change to mole. So you're given, the only number here is this, 112 ton. What is this ton? So since it's not something that you are familiar with, we have to give you what it means. So be careful. So mole of ethane, which is, alright, sorry, this is ethene. Mole of ethene would be C2H4 equal to 100,000 times 112 divided by the MR, which is 212 plus 41 equal to divided by 24 plus 4. So you actually get 4 million moles. And the third step is mole ratio. So from the equation, we can see that 1 C2H4 is to 1 C2H5OH. So the mole of C2H5OH would be the same, 4 million moles. So the question is asking for mass, alright? So let's convert to mass. So it's mole times MR. Two times 12 plus 6 times 1 plus 16 times 24 plus 6 plus 16 gives you 184,000,000 gram. You might be thinking, do I need to convert to ton? Not necessary, it's fine. And that's all. That's how you get your 3 marks. 1 mark, 1 mark, 1 mark. Yay! So So the next practice question. So let's take a look at the practice question. You can pause the question now to try. Alright, let's take a look. So same thing. First step, equation is given. Second step, let's change to mole. So there's a lot of numbers here. Let's take a look one at a time. First, 25.0 solution. This cannot change to mole. Convert to mole. Why? Because this is, you actually have the volume of a solution. You do not have the concentration of solution. So things are missing. So you cannot convert. So be it. Whereas the other one you can convert. Let's convert then. So mole of H3PO4 equal to 12.30 over 1000 times 0.150. So do recall, it's another trap. Volume is almost always given in cm cube. You have to be careful. You will get 0.001845 mole. And with that, you are done with the second step. Now we do the third step, ratio. So now they want you to find sodium hydroxide. So from there you can see is 1 H3PO4 is to 3 NaOH. So mole of NaOH would be 0.001845 divide by 3 or times 3. So be very careful. You times 3. 0.005535 mole. And you're almost there. So now they want you to find the concentration. So the concentration of NaOH is 0.005535 divided by the volume, which is 25 over 1000. You will get the final answer of 0.2214 mole per dm cube. 0.221 mole per dm cube. Do recall that the final answer needs to be 3SF. And that's how you get your 3 marks. Alright, so that's all for the practice question. So going back to the new content, your percentage U and percentage purity. So this is percentage U. So U refers to product, whereas purity refers to reactant. So product means all this is in terms of mass. So it's typically mass. So okay, my trick to you is this. So these two formula is important. But generally, right, what I can give you is you don't actually have to remember the word actual U, theoretical U, because these terms can make your head have a headache. Yeah. So my general trick for you is this. Whether it's percentage U or whether it's percentage purity, is always equal to the smaller mass over the larger mass. So this is the shortcut I can give to you. Alright, so let's look at an example. So the example is here. So take some time to look through and try and digest. Alright? So it is a very standard question. Okay, now after looking at the standard question, let's do some examples. So, let me show you how to do the first question. Then after that, the subsequent question 2, 3, and 4, you can use it as a practice question where you pause the video and you try first. So let's take a look at question number 1. So let's have an equation. So in this case, it says what? Hydrogen, alright? So H2, hydrogen is a gas, plus oxygen, oxygen is O2. It gives you water. So that's what is being told to you in the equation. So is this equation balanced? So as you recall, it is not balanced. So a quick flashback to the hashtag hack of balancing equation. First step, you balance the metal, the non-metal, the H, then the O. Oh, there are no metals, so ignore it. Non-metal, nope, H, then the O. So you realize that this is how you balance it. Alright, that's good. Then another hashtag hack, your hashtag hack to doing more questions. So we went through this just now, just a very, very quick recap. Balance chemical equation. Convert to mole. And mole ratio. So you have the equation. Very good. Then you will convert to mole. Let's take a look. So before you jump in and calculate, right? Think about it. Think about it. What do I mean by think about it? So this is a percentage yield question, right? It's all about yield, right? So yield refers to product. So an extra thing that I'm telling you now is this. That means the given mass of product given in the question, do not touch, or rather do not convert. Means it's referring to this number specifically. Do not convert. So that's the extra thing that you need to take note. So if it's a percentage yield, means product, means the mass of product that you have in the question, do not convert. Alright, so let's continue. So mole of hydrogen gas is 24 dm cube divided by 24 dm cube equal to 1 mole. And with that, you have the second point. Then you will use the mole ratio. So 2H2 is to 2H2O. So the mole of water would be the same, 1 mole. Alright. Then you're almost there. Mass of H2O is 1 times 2 bracket 1 plus 16 is equal to 18 gram. So now you notice you have two masses involved. You have 13.5, you have 18. So what it actually means, right, is this is what you should get. That means this is the 100% yield situation. That means by right, I'm supposed to have this much. But actually, I only get 13.5. That's why percentage yield in this case is 13.5, which is what you actually get, over 18, which is what you should get. Which gives you an answer of 75%. Alright, so take the time to digest this. After which, pause the video and try question number 2. Okay, now that you have done question number 2, let's look at how do we do it. So, first step, let's write the equation. So it says what? The rock contains iron, alright? So we have iron, okay, iron plus sulfuric acid. So this is something that you should be very familiar with, you're supposed to know. Give you hydrogen gas and iron 2 sulfate. So all this is given in the equation, in the question. You just read and you write down accordingly. The equation is balanced, well done. So that's the first step. Second step, so let's change everything to mole. But think about it. This is a purity question. Purity means what? Purity means reactant. Means the wise words. The given mass of reactant, because reactant, do not touch, meaning do not convert. So in this case, the number that we're looking at is this 60 gram, do not convert. And it makes total sense. Why? This person claimed that the rock is 100% iron. It's probably not 100%. That's why we need to calculate. So that means this is actually impure. You don't know what other things is inside. How do you convert? Okay, let's change to mole. Mole of hydrogen gas is 24 over 24 equal to 1 mole. Then you can do your mole ratio. So 1 H2 is to 1 Fe. Then you find the mass of iron that is actually present. So 1 times AR, which is 56 gram. So what does it mean? It means that this is the mass of iron actually present compared to the 60 gram, which is the sample. So therefore, in this case, percentage purity is the real mass, 56, over 60. Which gives you an answer of 93.3%, 3SF. Alright. So next question, let's take some time to try it. Pause the video first. Alright, let's approach question 3 and try. So you realize that question 3 is more difficult because it has the additional thing about your limiting reagent. So as you recall, I mentioned limiting reagent is the toughest question you have, which means this is a very, very, very challenging one. Let's try then. So A, balanced chemical equation. Alright, let's take a look. You have barium nitrate. So we recall that barium is group 2. Nitrate is NO3 minus. So that is BaNO3 2. And it's AQ. How do you know it's AQ? Because it's aqueous. Reacts with potassium sulfate. Potassium is group 1, so it's K+. Sulfate you need to memorize. So together you have K2SO4. And this is AQ as well, because again, if you look carefully, it is mentioned. So you might be wondering, am I supposed to remember this? In the later topics, you will actually learn things that allow you to tell, right, any salt, whether this salt is soluble or not, whether it's AQ, whether it's solid. But for now, it will be given to you because we have not reached there yet. So we don't need to worry. You worry has when the boat reach there lah. Potassium nitrate, so K plus and nitrate. So KNO3AQ, again, it is given. Barium sulfate, so barium and sulfate. So this is a solid because they said so. Alright, so that why is it 2 marks? Because 1 mark for the question, 1 mark for the equation, 1 mark for the state symbols, the correct state symbols. And you're done with question A. Let's look at B. Identify the limiting reagent. Alright, so you might be wondering, how do I do this? Never mind, let's take a look. So let's change, second step, change the mole. So let me bring this down as well so we can refer to it. So this is your equation, first step. Second step, change to mole. Alright, so mole of barium nitrate is 50 cm cubed. Remember the usual trick. So this is 0.005 mole. Alright. And you notice you have another set of numbers, 80 cm cubed of 0.075. Okay, let's convert then. Okay. Then recall what I've said before. If you have the mole of both my reactant, something is fishy. Remember the fish. Fishy. So that is very likely that there is a limiting and excess. So you have to prove it. So how do you prove it? You can use either number. So I'm just going to choose one of the number. So 0.005 mole of barium nitrate require the same mole of KNO3 for complete reaction. You might be wondering, how do I know that? Because from the equation, I see that 1 barium nitrate is to 1 K2SO4. So if this is 0.005 mole, this is also 0.005 mole. Alright. But the actual mole of my KNO3 is 0.006 mole. So this is actually more than needed. So with this, you know which is limited. So therefore, your barium nitrate is the limiting reagent or limiting reactant. Yay! Then you can go on to the next part to calculate the U. So hold on. U means product. Product means the given mass of the product do not touch. Do not touch. Do not convert. Which in this case is referring to your 1.0 gram. Okay, I don't touch. Fine. So to continue, do you use the limiting or do you use the excess to continue? So you'll use the limiting reagent to continue. So now 1 barium nitrate is to 1 barium sulfate. So mole of barium sulfate is the same. Then you can find the mass. (137) plus 32 plus 4 times 16 gives you 37 plus 32 plus 64 times 0.005. You get 1.165 gram. So this is what does this mean? This means that this is what you should get. But we actually only have 1 gram. So percentage yield is 1 divided by 1.165 times 100 equal to 85.8%. All right. So let's repeat for the very last question, all right? Just extra practice for you. So you can pause it and attempt this question. Okay, let's look at this. Calcium carbonate solid plus hydrochloric acid gives you water plus carbon dioxide gas plus calcium chloride solution. Oh, purity. Purity means reactant. Reactant means given mass of reactant do not convert, do not touch. Then you look at the question A. So that is referring to your 110 gram. Okay, let's not touch it. So now let's do the second step. Let's convert. (24/24) equal to 1 mole. Alright. Then we can mole ratio. One CO2 is to 1 CaCO3. So mole of CaCO3 is the same. Then you can find your mass or the actual mass. 40 plus 12 plus 3 times 16 equal to 100 gram. That means that the actual mass of calcium carbonate is 100 gram. But the sample is 110. So it's 100 over 110 times 100% gives you 90.9%, 3 significant figure. Alright, that's about it. Thank you. Bye bye.